We talked about the idea that there's two different styles. So we can use a list, or we can use what we used last week, a tuple. And the difference being that a tuple we can't change and a list we can change. And the reality is when we set them up, the only difference when we set up that list is one we use a parenthesis and one we use a square bracket around it. We can address them internally the same way. We get some additional features with lists, and we get those features because we can change things on it. So we can swap in and out items as on the fly. We can delete items. And so depending on our purpose, that's either a great, wonderful tool or it's a little bit of a hindrance. So we can pick whichever one we want to use. So one other data type that we haven't looked at is this idea of a dictionary. And so a dictionary pairs a list item and a definition. And so if I look up here at the front, we have 404 colon and then a definition. And so this works a little different. Everything else we've used as an index says we have a number in it. So 0, 1, 2, 3, 4. In this particular case, a dictionary allows us to use that first item actually as the index itself. So rather than addressing it as item 0, it's actually item 404, or item 1 would be Googling, and we can address them that way directly. And so we'll look at how that looks and what it looks like. So on the giant screen there, you can see up at the top, we've created something that looks very similar to a list or a tuple. And in fact, it looks a little more like a tuple because notice it's got a bracket in it. So it tells us that we're going to create a dictionary item. We don't have to do anything explicitly and say, hey, this is a dictionary item. Just by the fact we're using these brackets and the structure. The other difference is, notice each group has a colon between it and then a comma separating each group. Now, the fun thing about these are also mutable. In other words, they're changeable on the fly. So we could actually change this program and what's listed in these terms. So let's look at a couple items here. So first, notice we put the entire program in that loop, similar to what we've done before. So now everything is indented one tab because it's inside that while loop. So as long as choice is not equal to 0, so we don't put 0 in our menu item, this program will run indefinitely. So we input a choice. So our choices, then our menu becomes this list of items here. Notice we've got them identified by a comment, and those comments become pretty important as our program gets a little more complicated. So up here we have an exit. So if choice equals 0, so this loop will run, even though it says while choice is not equal to 0, it runs through this loop once even when it hits 0 and then exits. It just doesn't return back for another loop. So we can print goodbye, you could print thank you for playing, whatever you wanted to put in there. We do a second choice for the number 1. And if I notice here, it says look up a geek term. So term, so we're getting a variable set to term, and we say input, what term do you want me to translate? We then check to see if that term is in that entire dictionary item called geek. So if that term is in geek, then we pull up another variable called definition, and that's equal to the value of geek at position term. So notice we didn't use a value, we actually used that term itself or that index of a keyword. And so that's really powerful compared to a lot of other programming languages. We could do it in other languages. It'd take a lot more effort and a lot more code. If that term isn't in our dictionary, it's going to print, sorry, I don't know that. Whatever you've said, I don't know that term. We also have the ability to add our own. So notice here, if I look up at the second choice, we say, well, I want to add a term. So now we say, well, we input a term. What do we want to add? And that becomes the index. And we check again. We check to see, is it already existing? Because we don't want two of the same item, and in fact, that'd be an issue. We say, well, okay, then your definition equals the input of what's your definition, and then we print what has been added. If it already exists, then we flip this else, and it will come back up and ask again. So we can go back to the same thing. Here we can modify one to show that we can change one. So what term do we want to redefine? So we do the same structure. We check and see if it exists. We input what the new definition of it is, and then assign it to that value. And notice how we do that assigning. So geek, and then in position of whatever that item is we found, we slide in the definition. And then we can certainly delete it. So here we have the same type of structure. We get an input. We ask if it's in that particular list. And then we can delete it then. And then we have a new term, delete. So if I run this, so we can look one up. And I'm going to type in 404 because I know it's in there. 404 means clueless. So if you've been to a website that came up and said there's no page there, that's where that came from. So we can redefine that so we can change it on the fly. So I want to redefine 404. A missing student. Now if I look it up, so I'm going to look it up, 404. Notice it has already changed that in there. If we want to get rid of it, we can do that. So if I get rid of it, so let's press, which one is delete? 404. It checked, it's there, we got rid of it. So now let's see if we can look it up. 404. It's going to say, oh, I don't know 404 because we got rid of it. We'd have to add it back in there to do that. So it's a pretty quick little program, and it just shows you the power of those dictionary items. So if I'm writing a game, if I'm writing a program that deals with business, we can create those very, very easily. So on the bottom of page 143, they talk about the get method to retrieve a value. So that's an alternative method, different than what we're using here. So you'll notice how it works with the dotted notation. So make sure you've worked your way through here and look at this. How do I write up these key requirements? So a couple of things about these. You can't have the same key. You can have the same definitions, but that key has to be changed. So on the top of page 148, there's dictionary methods. In other words, how do we get values in and out of them? How do we set them up? So those little boxes and those tables are pretty important. So a couple of things we want to look at. So if we would have had this for last week's assignment, that would have been pretty easy to do. And in fact, a couple of students did look ahead and said, oh, well, let's use some of these tools. Now, that's perfectly acceptable. So click, get rid of this one. Yes, I do want to kill the process. But this idea of putting our entire program in a loop, very, very useful. That means we can run it as many times as we need to. So what I want to look at is how do we create something like a hangman game. So on page 148 and 149, we start looking at a hangman game. So I'm going to cheat and grab the program so we can evaluate it. That way I don't have to sit here and type. And again, make sure you find all this code in there. So hangman, edit. So we're going to start and take a look at a couple of things in there. So remember I said that we really don't have constants in Python, but we have some conventions to make things appear to be a constant. So in some programming languages, we very definitively set up what's a constant and what's not a constant. In other words, things that can change and things that can't change. In Python, we can actually change them. So one of the things we do is anything we don't want to change in our program, we use a little different naming convention. So notice how we've used all caps to name our constants. And that just is a clue that, hey, I'm going to set these up. Now the other thing they did was obviously they put it in a comment tag and said, hey, these are our constants. So what these are is if you notice here, it's pieces of ASCII art or just code to show that they, our hangman drawing. And notice we capitalized it, and it's one of these triple quoted strings, okay? And notice it's got parentheses, so that makes it a list, or does that make it a tuple? Which one can we not change? The tuple. So it's got the parentheses. So then we have a couple of others. So max wrong, so in other words, how many times we can be wrong, is set equal to the length of whatever our word guess is minus 1. And then we have a set of words that we're going to use. Now we can change those, add to them at any time we want to. So that's how we set up some of our text. And if you look in the book, it'll show you how we set up some of those. So in other words, we created a tuple, and if we wanted to add another word, so if we wanted to add Peru, for example, we could do that. It's constant in that we can't add or change that once the game is actually running. So here we have a couple of things. So our variables, we take the word, and that becomes random choice of words. So it picks out a random one, very similar to our assignment from last week. And then we have a variable called so far, and we assign that to however many dashes are in the length of the word. So that's what becomes that little dash, 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 dash to show you how many letters there are. We have a score called wrong, and we start out at 0 because at the beginning of the game you haven't scored any wrong. Numbers of wrong guesses, and then we have one for used. In other words, how many letters have you already used? So we're going to create in this particular case, notice we're creating a list. In other words, we want it to be able to be modified. And we set that equal, we put that in there and we set it equal to 0. So it eliminates anything that might have been in there. So our next step, let me see if I can make this a little taller. Okay, so our next step then is we're making a loop that will contain our for the majority of our program. All right, so in this particular case, we have a while loop, and so while wrong is less than max wrong. So in other words, the guesses we have, how many times we've guessed, is less than our max wrong. In other words, the length of our word minus 1. So as long as that's true, and notice we have an and condition, so both conditions have to be true. So this has to be and this has to be true for that loop to continue. So far, in other words, we've got a dash in there, is not equal to word. In other words, we set it up originally, it's got all the dashes in it. As we solve it, those dashes become letters. So as long as it hasn't become the word. So when it becomes the word, we exit out of this loop. And we exit out of it down here. And so if wrong is equal to max wrong, in other words, we've ran out of tries. The number of tries is equal to the number of letters minus 1. We're going to print hangman wrong and, oh, you've been hanged. Otherwise, we're going to print, you guessed it. And then it goes on to print the word was, and then it lets us escape the program, so it hangs it open again with our input. So that's our game. Let's run it to a point and see if those things hold true so far. So yes, we want to save it. Okay, so our hangman game runs, and notice now we've got our hangman structure. So this first item, notice how we're pulling those one at a time. So we pulled this piece, and then we'll pull this as we miss one. So far I've used the following letters and nothing. Here it shows my structure, so how many letters I have in the game. And so we get to enter a guess for a word. And I'm going to pick E. Yes, E is in the word. So the same thing we looked at before, we can check through there. So far the word is blank blank E, blank 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 E something. So nope, I've used E and T isn't in the word. R isn't. You've already guessed it, so we even have an arrow trapping in case you guessed an existing number. And so we can go through this. Escape out here in a minute. So I would like to notice how it's keeping track of all the letters I've used. And so it even lets me put in a value that we know isn't a alphanumeric character, and it says, oh, it isn't in the word. And notice my graphic, we were hung, so now the game is over. And we can press a key to exit, and now the game is ended. So let's take a look then inside of here and look at a couple of things. So we can get the player's guesses. So I'm going to scroll down. So we're going to print a couple of things when we start out this. So, and you notice the first time we ran it, it printed out just square brackets because we hadn't put any letters in yet. And it printed so far, and that so far here at this particular point at the beginning of the game is just that set of dashes for us. So we have assign a value called guess, and we put that as an input. And we do one other thing here. Notice all of our letters are here are uppercase. Well, we do that because the programming language makes a difference between upper and lowercase. And so what we've done is we made all of these uppercase, and then right here we change guess a little bit. So it started out as guess as an input, and then we just made it the uppercase of everything. So if I put in a lowercase l, it becomes an uppercase L. So here we've guessed what we're going to do. So now, if guess is in used, so we keep track of all those items we used. And notice when I tried to enter it twice, it hiccuped and said, oh, okay, you didn't get that right. So if it's in used, it's going to print you've already used that letter and gives you a chance to input it again. And notice that's in a small while loop inside of our bigger loop. So we're nesting the loop. What that lets us do, if we keep entering R 37 times, it's going to just keep looping back and forth and say, nope, you've used it, nope, you've used it. If we haven't used it already, notice here then we use that append to add it to the list of guess. So that list called used. So up here we had one called used. We used the dot append and we put in whatever this value here was into that list. And that's how that grows as we go. Here we have our check to see if our letter is in the word. So if guess is in Word, and again, that is very, very easy compared to other languages, print yes, whatever you typed is in the word. And then we change and we create a new so far to include that guess. So in other words, so far changes as we find letters in it. So we blank out new, so new becomes a null character. And then we said for I, so in other words, an index value in range of the length of the word. So in other words, for I of the length of the word, if guess does not equal word, and here we're just appending it in there. So we use this new as a temporary variable throughout this, notice. So we just created it just for this purpose. And notice here, so far, notice here we're taking a little slice of it, and we're just putting it in there, substituting in the guessed letter for that blank. And then at the end of this, we assign a new value to so far. So that changes in this particular step. And then our else, this happens then if guess isn't in the word, and we don't need to write an if statement for it because it's only one of condition. It's either in or it's out. If it's out, then we can just print, nope, your letter isn't in the word, so we can assign it a value on your score of wrong plus 1. So that is an entire game for Hangman right there. Now, the graphics aren't real interesting. It's the old ASCII style art, but it hopefully gives you an idea of how we can get through a game and how we could add some kind of a scoring system. Because right now, where we started at, so last week, let's take a peek. So last week, you took this word jumble and you had to add a couple of items to it. And the hardest part was probably adding the hint feature. So how do I add a hint feature? And I've left a couple pieces in here, and there are literally as many different ways as students, different ways we can create this. So I just wanted to point out a couple of different items that we could possibly use. I'll set up and put some of them out on the website so you can look at them in detail. The one method I recommended in class as one of the easier ones might be to create a second tuple. In other words, these match up, so your scrambled are very similar. But now that you've seen the dictionary term, you could have used the dictionary to do the very same thing. There is something called an index, so even though we picked a random choice, we could use an index command to find out what the index of the word that we picked. So if our random choice, I'm just going to scribble in here, so if our random choice was jumble, we could look at it and see what its index is. So its index in this particular case for jumble would be 1. If we know that that value is 1, then we can take hints and print that out for the user. And so that's a method we could have used. Some people did a variety of different things. There were some people that actually created a set of if statements and hard-coded it. Now, it worked, but it wasn't easy to scale out. So if I wanted to add additional terms, it wasn't very easy. So in other words, they had, if your guess or your jumble equals, Python, then you would output a hint for hint 1, whatever that might be. And then they would do an LF guess equal Python or whatever it is, jumbled. And so they would go through and do an entire set of those. And that works, but it may not be the best strategy long term. It worked in this game, but if I go in here and add additional answers, so if I said, well, this is my test game, and I only had 6 words, but my real game, I want to have 1,000 words in there, that's going to be a lot of if statements, and it's going to get a little bogged down. And so if we can come up with a programmatic way to come up with a hint, you're generally better off. One of the more interesting ones I thought was one of the students looked at that slice function and would slice off the first couple of letters of whatever. So if they asked for a hint, they would slice off the first maybe 3 letters and give them a little bit of a structure. And so I thought that was kind of an interesting approach that I had never thought about it quite actually. So there's a lot of different ways you could have come up with that. We will put some of those in our online so you can see a couple of examples. One of the issues we seem to have with a lot of students in it was, how do I make the game actually function? So they would have the hint piece, you would have the structure for a scoring system. So in other words, when it asked for a hint, they would get a structure, but it would ask the hint once and then exit, or there would be another structural issue. So make sure you've tested these once you get them. Run different scenarios, try them, work your way through. Even if I'm just looking at the code and I have to just write in my little notebook over here, okay, at this step, this would be. The other kind of tool you can use is when I'm trying to troubleshoot, one of the things I find very useful. So if I wanted to troubleshoot this, because I don't know what's going on here, maybe each one of these loops, I put in a print statement, and I can certainly put in a print statement to print out what jumble is on each step. And so sometimes those will help me by putting in extra print statements. Make sure you take them out. And so sometimes what you might want to do is just go ahead and put in a comment, test print for me or something. So that way you can use it as a troubleshooting technique, but you know which ones to get out of there again at the end of your program. So they're one of the hard things or the good things, depending on how you want to look at it in this class. Once we get into this a little bit, there's no right or wrong way to do things. There are, in some cases, better ways or less better ways, but if it works correctly, there may be 100 different ways to create the program code for one particular way to do something. So this is not the only way to do a hangman game. The things I will show you for the last week's assignment that students came up with are not the only ways to do it. Now again, a series of if statements might not be the best way, but did it solve the problem? Yes. But we also want to look at it in terms of scalability. So how do I manage or look at it in the future? Or if I'm handing it off to somebody else, how do I look at that? So let me log back into Blackboard here. Find our class. Be nice if Blackboard would stay logged in a little longer, but all right, so assignments. Slowly. No. We're already now up to week 11. And so your assignment this week, so we looked at dictionaries, lists. So this week's assignment, in terms of programming, is we want to create a program that prints out a list of 15 words in a random order and not repeat any of those words. Then, if you want to try to earn some extra credit, I want you to add the ability to add a new word to this list and display this list. And you have to be able to do it multiple times. In other words, you can't do it just once. It's got to be in a menu type item so that we can do it multiple times. So if you wanted to expand your list from 15 words you may want to expand it to 25 or 30 or 40 words in there just by adding to it. So when I start looking at something like that, the first thing I always do, or I try to do, is I'm going to write it in kind of a pseudocode. So I don't need Python, I don't need anything else. I just want to think about what kinds of things do I need to do. So I know I want to create a list of words. So somehow I have to create a list of 20 words. Now, notice that I can do a couple of structures. I could do a tuple, but a tuple, am I going to be able to add to it if I want to try to get the extra credit? No. So I'm going to say, well, you know, I think it would be better to use a list. So I can start looking at a couple of things that way. I can start looking at what kinds of things do I need. So in my program, I know at the beginning, I know I'm going to have to use that import random. So I can start thinking about this. I know somehow I need to scramble this list. And I need to print out this list. And so that's at the bare minimum. But how do I scramble that list? And how do I then print it out and not repeat any of the items? What kind of techniques do I maybe have out of this chapter to do that? Is there something we've looked at? So in all our sample code, is there something we've seen that would allow us to scramble an entire list? Or is there a method to that we could utilize? Now, obviously, that we can use that word choice. So if I look at, let's see here. Where's my jumble? There it is. So notice this one here, I could use this random choice of words. What's going to be the one problem with that? Can I create a program that would print out our list of words using this random choice? So what if I did this? So one of the things I like to do is take existing code because it gives me a little bit of a structure. So I know I'm going to import random. And in fact, I may use the top piece of that just to give me a structure already. So I know it's got a list of words. And I know that I can grab a word from all of those. And I don't need some of this, so I'm going to delete that. And I know I'm going to delete all of this. But it just gives me a quick place to start. And I'm going to leave that last line in there because that's kind of important. But I need to think about my structure before I ever start sitting down and coding. So right now, if I put in a print, that's going to print something. So let's run that and see what happens. Run module. Okay, yes. Okay, and it printed out xylophone. Well, I want to print all the lists in there in random order, don't I? So let's assume I have my 20 in there. Could I just create, we know we could do a for loop for I. What's our structure for a for loop? You remember? So if I don't remember something, so the other thing that's really useful in this code is I can go and look at what other ones do. So notice here I have a for loop. So I like to go look at existing code. Sometimes that's the easiest way I can go in and remember something. So for I in range, okay, so that maybe isn't exactly what we're looking for. Or is it? So notice here, so I'm going to take that very quickly, because this is the one class I'm going to say copy and paste can be your friend. So instead of creating my brand new one, I'm going to do this. And I want to look at a couple of things. So I notice I have to change it because I have a list up there called words. Okay. And I don't necessarily need some of this. So we're going to change that a little bit. So for I in range of the length of the word. So in other words, it's going to cycle through as many times as there are as this length of words. Does that make sense? So to do a little testing, I'm going to print out a couple things. So I'm going to print I, and notice I got to put that in brackets because I'm just curious what I is going to look like through there. And then I'm going to print, I always want to capitalize that. Okay, so, and then I'm going to print, well, hold on a second. Let me add this piece up first. I'm going to put this up here. So that's going to run as many times as there are in there. And then I'm going to print word. Okay. So let's see what happens. So run. Okay. So notice I put this 0, 1, 2 because I wanted to see if that is indeed, did it print out however many times there's in that list. So let me check. 1, 2, 3, 4, 5, 6, 7. Okay. And notice it printed 0 through 6. So it really did do 7 times. But notice what it did. It printed out my list of words, but do I have some that are the same? So we have an issue. How do I solve that issue? So I'll show you one method and one thing we could do. So this right now is a tuple, and I'm going to change that from a tuple to a list. And so all I have to do is notice I'm going to change this at the end, that bracket. And now I can change the items in there, right? Okay. So that's kind of interesting, one way to do it. So now I've made a list that I can change. So all I had to do to change that from a tuple to a list, what if, and so let's see if I can find the page that we looked at there. So there is a page in here where we looked at the dictionary terms, and we've said we could delete values. Well, is there a way we can delete a piece out of a list? So if I look all the way back on page 127, we show you how you can delete an item out of inventory. So here we look at words, and it's going to give us a word of random choice. Well, there might be a slightly different way to do that. We get that random choice of words. So if I could somehow delete whatever is in words, so and so I'm going to open that, and so I got to figure out how I could figure out what is coming out of here. Now, There's a problem with this, and we'll show you what one of the problems with this is. How do I know what that is in terms of a word? Because I don't get that index, and here I need to put in an index to be able to delete the proper one. So there's a couple of different ways I could do that. I could change this piece here, and instead I could do something where I picked a random value, but if I created a structure like this where I could come up with that, and so maybe there is a way to do that. So there is that index function, remember I talked about? That's a whole index. I don't know what, let's look and see. So python.org is kind of our authoritative source. So notice in Python, there's documentation. And so let's look at the 3x documents because that's what we're working in. And so I want to look at index. And so I'm just going to do a search. And so it searches all of the help for 3.4. So there's a ton of different index pieces in here. So we can look at return the smallest I such that I is the index of the first occurrence of X in the array. Well, that seems a little not clear, doesn't it? But let's see what it's really saying here. So array.index. So that index that we look at, so if this doesn't look clear, so we know we maybe want to use an index. We can even just do a search Python index method. And notice here, so there's a ton of different resources out there. So here, for example, is a syntax for an index method. So string 1, string 2. So this particular program, so it says here's string 1, and it will actually allow us to pull out that string. So that's one method you can use. So back here. So come back. So I could look at this, and notice I haven't saved any of that. And we could use that index array and pull out the proper index. So, you know, you could say temp equal the index of whatever this word is, blah, 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 blah. So you can do that. Now, this is interesting because I could print a list of every word in here, and I could do that by, and they would not repeat each other because after I print them, it makes the word leave the list. Now, what's the problem with that? So I've destroyed my list in the process. So maybe that's not the best method to work with. It would work, but again, it's a choice of, if I look ahead a little bit and I think, well, I'd like to earn that extra credit, how am I going to add to this list on a continual basis if I destroy it every time? So let's look at the code for, I should have had that one still up, there we go, for Hangman. And so the Hangman game might give us a little clue on something on how we could do that. So one of the things in the Hangman game, now in this particular case you're looking at just a letter, but we could use the same type of technique. So we create a variable that's got a list of every item we've used. So in this particular case, we created a second variable, and we said, we're going to compare those, or we concatenate it together, and we're going to compare it. So in other words, here we set up a small while loop while guess is in used. Print, you've already guessed that letter. And so we could do something similar to that. And we don't necessarily even need to use, let me go back to this one. So we wouldn't necessarily even need to use the entire word itself. We could use the index for it if we wanted to. There's a ton of different ways we could do that. But all the tools are in this chapter for how to think about that. But it sounds amazingly easy. I'm going to print a list of 20 words and I'm going to scramble their order and then print out that list. Now, there may be a method to scramble an entire list. So maybe that bears a little investigation. We didn't talk about it in this chapter, but does Python have a method to scramble an entire list? If I could just run one line command and say scramble a list, that would be really slick, because then I could print it out in order and it wouldn't repeat anything. You might try to look at that and see if there's a way to do it. There certainly is a way to sort a list, which is different than random, obviously. But if there's a way to sort a list, maybe there's other things. So if I go back to Python, and I go backwards here, so what's new in Python? There's all different kinds of things. How-tos, here's how to port code, but maybe I want to do list methods. So built-in types, expressions, and so maybe I'm not getting quite what I want. I know that I can sort a list, so maybe it's in the same area. So, Python method, built-in types. So lists, it says lists are mutable sequences. We can store collections of homogeneous items. So in other words, generally we store the same type of items. So here we can do a sort. So there may be other ways we can do that. So I would look at what kind of items we can do. So sequence types, so we can put things in, remove them, append. So there's a lot of different items we can do. How can I create a list of those? So one other option. So you might be able to scramble that list somehow. Maybe I scramble that list and I create a second list that I use for displaying. We could certainly do that. So the first thing you need to do is work your way through the chapter, look at all the items we have in there, and then start, as you work your way through, if you have this idea in the back of your head, oh, I can use this to scramble that entire list. I mean, obviously, I can print a list out scrambled, but how do I prevent it from being used already? How can I assign it to another list if I want to? How do I create a list that's changed and output it? So that is your challenge this week. And this one may require you to put on your thinking caps a little bit in terms of how do I do it? And it sounds very, very simple. So again, there's a chance to earn some extra credit. So keep that extra credit idea in the back of your mind, because obviously we could create one where we deleted it as we go through. Not very useful in terms of being able to modify it, unless you use the delete function is to print it out. Certainly a possible method if I assigned it a temporary one. So in other words, I assigned right up here, so I assigned temp equal words. So if I then printed can I do that? Just assign an entire list very quickly? Well, let's see what happens. Again, sometimes we have to, let's see, I need to take that out so it doesn't delete anything bad. Okay, so we could run this. Let's see what happens. So notice, oops, didn't mean to make it quite that big. Notice up here, at the very beginning of our program, it printed out that entire list, didn't it? So I could assign another variable to that list, and I could use my delete function and still leave my original list alone, couldn't I? So a lot of different ways to do this. There are probably 1,000 different ways you could do this, which maybe that makes it a little harder to think about. But go through the chapter, look at what we're doing. Obviously here I came up with a random list, but it's duplicating some of those items. So how do I do that? How can I create a list to print that out? Maybe it's as simple as creating a list dynamically on the fly and checking each time and then going, oh, nope, else, do another one. That would certainly work also.